Okay, Assalamualaikum warahmatullahi wabarakatuh dan very good day to all of you. So, selamat kembali kepada kita punya semester. So, now we are again in week 10. Okay, sepatutnya kita dah habis week 10 tetapi kita dah adakan cuti bencana seminggu disambung dengan cuti perayaan seminggu. So, minggu ini adalah minggu ke-10 dan kita akan ada lagi 5 minggu termasuk minggu ini sebelum ke final exam, di mana minggu yang ke-10 ini akan diletakkan di dalam minggu ulang kaji. Maksudnya ke depan lah. Okay, so minggu ulang kaji awak akan menggantikan minggu cuti bencana menyebabkan awak tak ada minggu ulang kaji. So hopefully you can catch up with all the syllabus for all subjects. Okay, because after 5 weeks ni awak akan terus face the final exam. Okay, so before kita cuti bencana dan cuti perayaan pada week 9, kita dah selesai tengok how to solve the non-homogeneous higher order differential equation by using the variation of parameter VOP. Okay, before that, a few class before that, we see on how to solve the higher order differential equation. Our chapter 4 is about higher order differential equation, where we start with the homogeneous higher order differential equations. Okay, and then we see on how to solve the non-homogeneous higher order differential equations. The first one is by using the superposition principle to find the YP, and then to find the general solution we combine YC complementary solution and the YP particular solution. Okay, and we find YP by using superposition principle, di mana awak ada table yang you need to refer to see the form of YP according to the function on your right hand side. Okay, here is the function on the right hand side. Okay, and then we see on how to solve the non-homogeneous differential equation by using annihilator approach, where the annihilator approach help you to find the form of YP particular solution, but the process and the method is still the same as superposition principle. It's only help you to form the particular solution, okay, by using the annihilator parameter. And then we learn on how to solve our higher order differential equation by using variation of parameter, where in the variation of parameter you need to find the Wronskian value, okay, and a few steps that you need to follow to solve our higher order differential equation. So now we are on the last topic for our chapter 4, higher order differential equation, which is the Cauchy-Euler equation. So Cauchy-Euler equation is one of the higher order differential equation. Okay, nama dia adalah Cauchy-Euler. So what is the Cauchy-Euler equation? If you can see here, the given Euler equation in the form of ax squared d square y dx square plus bx dy dx plus cy equal to fx. This one is the higher order differential equation since it involves a second derivative. Here you have the first derivative and your dependent variable y. Okay, and you can see here the constant, the coefficient. Okay, the coefficient in front here for all the derivative and also y is not a constant as we do previously. So before this, when we are solving our higher order differential equation by using superposition principle, by using the annihilator approach, by using the variation of parameter, you can see that all the coefficient in front here is the constant only. But Euler equation is the equation that consists of non-constant coefficient of the dependent variable and its derivative. Okay, so this one cannot be solved by using the method of undetermined coefficient, superposition principles, and also the variation of parameter that we learned before. Okay, so if you can see here, you have a with x squared. Okay, dia bukan constant semata-mata, tetapi you have a variable here. You have b with x, and you have the constant c with the dependent variable y. So whenever you see your coefficient is not in the form of constant, means you have your Euler equation. For example, if you have 2x squared d square y dx square plus 4x dy dx equal to ln x. So this one is the non-homogeneous Euler equation. Why is non-homogeneous? Because you can see on your right hand side is not equal to 0. Homogeneous is when your right hand side here is equal to 0. So now is it not equal to 0, means this one is non-homogeneous, and this one is the Euler equation. Why is Euler equation? Because you can see the coefficient in front of your derivative is not a constant, but it consists of a constant and variables. Okay, so itu adalah how to identify what is the Cauchy-Euler equation. So if we are solving the Cauchy-Euler equation, we need to use another method. Okay, we will see 3 cases for Cauchy-Euler equation. The first case is for the homogeneous Euler equation. So when we talk about the homogeneous Euler equation, it means that we have the equation in the form of ax squared d square y dx square plus bx dy dx plus cy equal to 0. Okay, when we talk about the homogeneous, means the left hand side here is equal to 0. So when we have the homogeneous differential equation, we need only to find what is the complementary solution yc. No need to find what is particular solution yp. So to find the complementary solution yc by using the undetermined coefficient method like before, but it's just a little bit different in the form of general, in the general form of the yc. Okay, so you have 3 types of root. Your root letter will be in the form of m. Before this, when we do the undetermined coefficient method, our root is in the form of lambda. Okay, because we substitute the derivative with the lambda. But now, your root will be in the form of m. So, if you have the value of m1 and m2, if you have 2 roots, okay, it depends on your order of your derivative. If you have second derivative, means you have 2 roots. Okay, you have 2 solution, you have 2 roots. Okay, so if you have the third derivative, means you have 3 roots. Okay, so if you have 2 roots and your root is the same, real and equal, therefore your complementary solution will be c1x m1. Before this, yc for homogeneous differential equation is c1 exponent lambda 1 plus c2 exponent lambda 2. But now we change the exponent to x. Okay, and because of it's equal. Okay, because it's a root that is real and equal, then you have your complementary solution c1x to the power of m1 plus c2x to the power of m1, because m1 and m2 is the same, so you can use either one. Okay, and because it's the same root, you need to add ln x at the back. Okay, for the second one. If before this, for homogeneous differential equation, for the root that is real and equal, the yc will be c1 exponent lambda 1x plus c2x exponent lambda 1x. This one is added because of the root is the same. But for this case, for the Euler equation, the ln x is added when your root is the same root. Okay, and the general form will be in the form of c1x to the power of m1 plus c2x to the power of m1 ln x. Okay, it's for real and equal roots. If you have a real and distinct root, means that you have the different value of m1 and m2, your complementary solution yc will be in the form of c1x to the power of m1 plus c2x to the power of m2. There is no ln x because m1 and m2 is the different value. Okay, and the last one is when you have the complex root, okay, where complex root will be in the form of alpha plus minus beta I, and usually we will get the complex root by solving our quadratic equation by using the quadratic formula, which is negative b plus minus square root of b square minus 4ac divided by 2a. Okay, so this one is how to solve the quadratic equation that cannot be factorized. So you can use the quadratic formula, and if you have a complex root which involve the value of alpha plus minus beta I, the complementary solution will be in the form of x to the power of alpha c1 cos beta ln x plus c2 sin beta ln x. Before this, when we are solving the homogeneous differential equation that have complex root, our YC is exponent lambda 1x C1 cos beta x plus C2, exponent alpha x C1 cos beta x plus C2 sin beta x. But now, for the case of Euler, exponent will be x to the power of alpha C1 cos beta ln x plus C2 sin beta ln x. Okay, so this one is three form of the YC if you are solving the homogeneous Euler equation. So what is Euler equation again? Euler equation is the equation that have the non-constant coefficient for its dependent variable and its derivative. Okay, so kita nak tengok soalan yang pertama. Solve x square y double prime. So y double prime is d square y dx square minus 3xy prime minus 2y equal to 0. So the first one, you can see that your right hand side is equal to 0, means this one is the homogeneous Euler equation. Okay, why is Euler equation? Because if you can see here, the coefficient is not a constant, but it consists of constant and also a variable. So how to solve our Euler equation? Okay, homogeneous Euler equation is you have step number 1, which you need to let y equal to x to the power of m. Don't ask me why. Okay, you just need to start with letting y to be equal to x to the power of m. Okay, let y equal to x to the power of m. You cannot let y to be any other's value, but you need to let y to be equal to x to the power of m. And then we need to differentiate y 2 times according to your equation. If you have only second derivative, means you need to find the first derivative and the second derivative. But if in your equation you have third derivative, means you need to find y prime, y double prime, and y triple prime. So it's according to your differential equation. Now, if you check on your differential equation, you only have up to y double prime. So let's find what is y prime first. Okay, so m bring to the front x and the power u minus 1. So this one is y prime. Okay, differentiate y. And again, we need to differentiate y prime to get y double prime. So this one, you bring to the front, you will get m multiplied by m minus 1 x minus 1. So you will have m minus 2. Okay, just do a process of integration. Now, what you need to do is, you need to substitute all value here, which is y, y prime, and y double prime in this original equation, where what you need to do is, you need to substitute your y double prime, your y prime, and your y with this one. Okay, so let's substitute. You have x squared here. Okay, you have x squared y double prime minus 3xy prime minus 2y equal to 0. So substitute y double prime with this one. You will have x to the power of 2 m squared minus m. I expand this one. Okay, m squared minus m x m minus 2. Okay, minus with 3x. So substitute y prime. Your y prime is this one, mxm minus 1 minus with 2y. So your y is x to the power of m equal to 0. Okay, so now what you need to do is you need to expand your equation. So you can see here you have m2 minus m, okay, and you have x2 multiplied by xm minus 2. So when you have x to the power of 2 multiplied by x to the power of m minus 2, what you need to do is you just need to add up all the power here. So what you have is m squared minus m x2 plus m minus 2. Okay, so 2 minus 2 is 0. So what you have here is m squared minus m x to the power of m minus. Okay, so you have 3m. Okay, you have here 3m. And then you have x to the power of 1 multiplied by x to the power of m minus 1. So it will be 3mx. The power you need to add up because it's multiply. So 1 plus m minus 1. 1 minus 1 is 0. So you have negative 3mx to the power of m. And you have here negative 2x to the power of m equal to 0. Okay. So now if you can see all of the term have x to the power of m, so what we can do is we can factorize it out. So we factorize x to the power of m. So here you only have m squared minus m. Okay. Here you factorize x to the power of m, you only have with minus 3m. And you factorize x to the power of m, you have minus 2 equal to 0. Okay, this one you bring to the right, it will become 0 divided by x to the power of m is equal to 0. So what you have here is m squared minus 4m minus 2 equal to 0. Okay, so now you can see that you get your quadratic equation. What you need to do is you need to factorize, okay, or find the value of m1 and m2. You can use your calculator, but because I cannot factorize this manually, I will use the quadratic formula, where from the quadratic equation here, the value of a is equal to 1, the value of b is equal to negative 4, and the value of c is equal to negative 2. Therefore, by using the quadratic formula, negative b plus minus b squared minus 4ac divided by 2a, I will get negative 4 plus minus square root of negative 4 square minus 4, 1, negative 2. Okay, divide by 2 multiplied by 1. So what I have here is 4 plus minus negative 4 square is 16. 16 plus 8 is 24 over 2. So from here I get 4 plus minus square root of 6 square root of 4, because it's 24, right? So divide by 2. So square root of 4 is equal to 2. So what I have here is 4 plus minus 2 square root of 6 divided by 2. So this one can be simplified. Okay, so what I have at the end is 2 plus minus square root of 6. Okay, therefore, my m1 is equal to 2 plus square root of 6, and my m2 is equal to 2 minus square root of 6. Or you can simply calculate by using calculator. You will get the point. The decimal value is okay, is accepted. So now if you can see, you have the different value of m1 and m2. Okay, so when you have a different value of m1 and m2, this one is your complementary solution, where you will have your yc equal to c1x to the power of 2 plus 6 plus with c2x to the power of 2 minus 6. This one is your general solution. Because this one is homogeneous differential equation, we only have yc, complementary solution. We didn't have any yp, particular solution. Okay, so let's see the second example here. Solve 3x squared y double prime plus 6xy prime plus y equal to 0. So you can see this one is the homogeneous differential equation because this one is equal to 0. And this also the Cauchy-Euler equation because your coefficient here is not a constant but it is a constant with a variable. Therefore, you cannot use the previous method but you need to use the method to solve Cauchy-Euler equation where we start with our step 1 letting y equal to x to the power of m. Step 1. Okay, and you check in your equation you only have y prime and y double prime, means you need to find what is your y prime. Again, bring m to the front, you will have mx m minus 1, and you need to check to find your y double prime, so it will become m minus 1 to the power of m minus 2 because you minus 1 again here. Okay, so now you already have your y prime and y double prime. You need to substitute all this value inside your equation here. So you have 3x squared y double prime, this one is your y double prime, m minus 1 x m minus 2 plus 6x y prime, this one is your y prime which is mx m minus 1 plus with y is your x to the power of m equal to 0. Okay, so now you need to simplify. Okay, you can see here you have 3, m multiplied by m is m squared minus m. Here you have x squared, here you have x m minus 2, 2 and minus 2 is 0, so you have x to the power of m here. It's just the same as before. Okay, so plus with 6m x power 1 minus 1 is 0, so you have power m. Okay, it's actually like this. X multiplied by x minus 1 is actually x this one is power 1 plus with m minus 1, so 1 minus 1 is 0. You only left with x to the power of m. Okay, so this one is the idea. Alright, is equal to, it's plus with x to the power of m here is equal to 0. So now what you can do is, you can see you have your xm here, you have your x to the power of m here, and also x to the power of m here. You can factorize it out. So you have x to the power of m in front. Here you have 3m squared minus 3m plus with 6m plus with 1 equal to 0. You bring x to the power of m to the right, so it's finished because 0 minus x to the power of m is equal 0. So you have here 3m squared plus 3m plus 1 equal to 0. This one is your quadratic formula. You can try to factorize by using calculator, but you will surely get the complex root. Okay, so I want to factorize this by using quadratic formula, negative b plus minus square root of b square minus 4ac divided by 2a. From here, I get the value of a is equal to 3. The value of b is equal to 3 as well. And the value of c is equal to 1. Okay, so negative 3 plus minus square root of 3 square is 9 minus 4 multiplied by 3 multiplied by 1, 4ac divided by 2 multiplied by 3. So what you have here is negative 3 plus minus square root of 9 minus 12 is negative 3 divided by 6. Okay, so square root of negative will be complex number. So what you have here is negative 3 plus minus square root 3i divided by 6. So this one can be written as negative 3 over 6 plus minus square root over 3 over 6i. Okay, so you can simplify. Negative 3 over 6 is negative 1 over 2 plus minus square root of 3 over 6i. So directly this one is your alpha and this one is your beta, because for complex root we will get the value of m in the form of alpha plus minus beta I. So this one is your alpha and this one is your beta. So when you already have your alpha and beta, the general solution for complex root is this one, where you will have your complementary solution YC equal to x to the power of alpha C1 cos beta ln x plus C2 sin beta, your beta is 3/6 ln x. So this one is the general solution for your Euler homogeneous Euler equation. Okay, homogeneous Euler equation. Okay, let's see one more example here. You have solved 4x squared d square y dx square plus 8x dy dx plus y equal to 0. Again, we can see here is homogeneous because it's equal to 0. And this one is an Euler equation because your coefficient here is the constant and variable. Therefore, you cannot solve by using the variation of parameter method, by the annihilator approach, by the superposition principle. You only can solve it by using the method that we learned before, where we need to start with letting y equal to x to the power of m. And you can check in your equation, you have y. You have y prime and y double prime means you need to find what is your y prime. Again, it's the same thing, mx m minus 1, and y double prime will be m minus 1 x m minus 2. Okay, so now what you need to do is you need to substitute all this into your equation. So you will have 4x squared m squared minus m x to the power of minus 2, x to the power of m minus 2 plus 8x mx m minus 1 plus with x to the power of m equal to 0. Okay, so we expand here, we will have 4 m squared minus m x 2 x m minus 2 plus 8m x1 x m minus 1 plus x m equal to 0. Okay, so this one you can simplify, plus and minus is 0. Also this one plus and minus is 0. So what you have here is 4m squared minus 4m x to the power of m plus 8m x to the power of m plus x to the power of m equal to 0. Okay class, now we factorize out x to the power of m. So we have in the bracket 4m squared minus 4m plus with 8m plus with 1 equal to 0, and you left with 4m squared plus 4m plus 1 equal to 0. So you will get the value of your let me see, I can factorize it, 2m plus 1 and 2m plus 1 equal to 0. Okay, so the value of m1 is equal to m2, which is negative 1 over 2. Okay, so now you have the real and equal root. Okay, so your general solution will be in the form of this one, where you will have your YC equal to C1 x to the power of negative 1 over 2 plus C2x to the power of negative 1 over 2 ln x. You need to put ln x because the root is the same. So this one is your complementary solution and also your general solution of the Cauchy-Euler differential equation for homogeneous case. Okay, so you have the first case here, the real and equal root. Okay, you have the third case here, complex root, and you have the second case here, which is the real and distinct or different root. Okay.